Hi, my name is Alan Edwards, and in this Estranged development blog I'm going to show you how to make a blueprint component that can be added to any actor that makes lights flicker. So there's two parts to this. There's the stationary light, which you can see is flickering, and there's also the emissive material on the light on the ceiling. And these things work together in sync to make it look like the light is flickering. So let's go ahead and just eject here for a second and look at this. So here's BP flicker, this is our blueprint, and there's also here this flicker curve. Now if we take a look at this one, we can see that's the one that's currently playing. So it just adds a bit of variance, a few spikes in there. This is quite a spiky flicker. So we can also change this. If we change it, we want to change the light completely. We can use a curve that, say, only has red in it, which makes it look very unnatural for this light, but it unlocks these possibilities. So you can see that that's actually affecting the color of the emissive material and the light on the ground. So let's just switch that back because I don't think that looks very good. What else do we have here? We have this flicker as well. That one's interesting. That one has a bit of a blue twinge to it because it tones down the other colors here. So let's go ahead and put it back on Flicker 02. I think that's the one I like the most. So you see here is the flicker component. It's also on this light here. Let's dive in and have a look at how it works. So there are two portions to it. The first is the begin play event here. Now this one allows us to do three things. So there's some quite expensive setting up that we need to do when we start this component up, and that is first we need to make a list of all the lights that we can affect. This is done by looking in the parent component, and we also need to make dynamic material instances of all the materials that we want to affect. So let's go through the first thing first. So firstly we get the owner of this actor component, and we get all of the components by class of light components. So that's all the components that inherit light components. So spotlight, point light, all of the different lights inherit this base. Then we check to see if the mobility of the current light we're iterating over is not static, because we can only affect stationary and movable lights. If it is not static, then we add it to our lights array. That one's quite simple. Then we go down here to the second thing that we do, get the owner, get components by class, primitive component, and then we loop over the primitive components. For each one, we get the number of materials, and then loop over those, and then get each material, and then get the base material from each material. And that means that we can check what each material inherits from. So let me just show you something here. So this assumes that you're using one parent material for all of your emissive materials. So this MI bulb on is a instance of M surface emissive. And M surface emissive in Estranged allows you to set a vector parameter that's directly linked to emissive color. So here we go. The default for this particular material instance is 1. So if we go back to BP flicker, you see here that we're actually checking the base material of our current material against M surface emissive. This is just we just set this here just as a constant, essentially, just to check this against. So if they are equal, then we know that we can change that emissive parameter. So we go ahead and create a dynamic material instance based on the current material, and then add it to our materials array. There's also one other piece of setup here. Now let's disconnect this and see what happens. So this is our third piece of setup. And you notice now I've done that, both of the lights flicker at exactly the same time. Let's go back into this flickering blueprint and connect that back up. Now you see this takes the flicker curve and gets the time range from it, and then it gets a random float in that range. And when you do this for each component, you'll see that each component gets a different random value, and it means that the flickering actually starts at a different time. So it makes them look completely independent of each other, which is quite a good effect. So let's go back there. So that is actually all the setup that we do on Begin Play. Now ideally this would go in a construction script, but as I mentioned in the previous video, actor components don't actually have construction scripts, which I think I'm going to ask about on the Unreal Engine forums later. So let's look at what we do every tick. So every tick we take the delta seconds and then we add it to the time, and we do some checking here just to see if the current time range is greater than the maximum time of the flicker curve. So if it is, we just go ahead and use the minimum time instead, because we need to wrap around. If our flicker goes from 0 to 1 and then delta seconds pushes us over 1, we need to go ahead and wrap around back to 0. So then we set time here, and we do two things. We firstly loop over our lights array, do that, and then set the light color based on the linear color value from the curve at the time that we're currently at. So I can show you how this works in game actually by just exposing these as public. So if we go ahead and do this, then eject. If I go ahead and look at BP flicker here, you'll see that this time value is constantly wrapping around, and we also have our arrays of lights and materials here as well. So that's just showing you what it's actually doing. So let's just get back into it. BP flicker, let's make those non-public, because they don't actually need to be public at all. And then the second thing that we do after setting the color of the light is we loop over our materials and then just set the emissive parameter value. So here's the emissive parameter. It's of type name. This is just basically a constant like I did here, so I can set it as a variable on the blueprint rather than defining it in the nodes. You can actually just type it here as well, but this kind of makes it a bit neater. So we set this emissive parameter. Again, do exactly the same thing. Get the linear color value from the curve at the current time and set it. And this is quite a simple thing to do, but it adds some depth to the scenes, and I think it's quite powerful. Okay, that's it for this development blog video. Thank you very much for watching.